Morning all of you. I am Dr. Pradeep Kumar, working as Assistant Professor in St. Peter's Engineering College, Autonomous, Hyderabad. In the today's session, we are going to discuss about the differences between the atomic orbital and molecular orbital. In the same way, differences between the molecular bonding molecular orbital and anti-bonding molecular orbital. Okay, these things we are going to discuss in this session. Actually, we have been learned about the concept of the atomic orbital, molecular orbital, and bonding molecular orbital and anti-bonding molecular orbital in the previous classes. But today's session we are going to discuss specifically differences between those orbitals. Okay, what are the main differences are there in between the atomic orbital, molecular orbital, as well as bonding molecular orbital and anti-bonding molecular orbitals. Okay, yeah, we'll see what are the main differences are there in the atomic orbital and molecular orbital. Then we'll discuss about the bonding molecular orbital and anti-bonding molecular orbital. First, we'll check about the differences between the atomic orbital and molecular orbital. Okay. Now, we will check the differences between the atomic orbital and molecular orbitals. In the first point, the atomic orbitals are found in atoms, but the molecular orbitals are found in molecules. Okay, the atomic orbitals are found in atoms, the molecular orbitals are found in molecules. The next point, the atomic orbitals are monocentric. The atomic orbitals are monocentric as it is found around a single nuclei. These atomic orbitals are a monocentric one, monocentric orbitals. That means the electron cloud will be found in around the single nuclei. Okay, in the atomic orbitals, the electron cloud will be found in around a single nuclei. But in the case of the molecular orbital, it is a polycentric orbital. It is a polycentric molecular orbital. That means here the electron cloud of the molecular orbital will be found in around more than 2 different nuclei. Okay, here the molecular orbital is a polycentric one. That means the electron cloud of the molecular orbital will be found around more than 2 different nuclei. The next point, here in the atomic orbital formation, here we will discuss about the Schrodinger equation. Okay, the Schrodinger equation will be involved in the atomic orbital formation. But in the molecular orbital formation, as we discussed in the previous class, LCO method is involved. That is, linear combination of atomic orbital will be involved in the formation of the molecular orbital. In the formation of the atomic orbital, we will have the Schrodinger equation. In the formation of the molecular orbital, we have linear combination of atomic orbital method. That is, LCO method is involved. Now coming to the next point, in the atomic orbitals are named as s orbital, p orbital, d orbital, f orbital, like that, isn't it? S, p, d, f. The atomic orbitals are named as s, p, d, f. The molecular orbitals classified as 2 types. The first one is bonding molecular orbital and second one is anti-bonding molecular orbitals. In the bonding orbitals, in the bonding molecular orbitals, we have sigma and pi orbitals. In the anti-bonding molecular orbitals, we have sigma star and pi star orbitals. Okay. And coming to the next point, atomic orbitals have the fixed shape. Atomic orbitals are having the fixed shape. That means, if you check here, for example, if we take the S atomic orbital, the shape is fixed, that is spherical one. S orbital is always having the spherical shape. P orbital is having always dumbbell shape, isn't it? P orbital is always dumbbell shape, and D orbital is always double dumbbell shape. That means here the atomic orbitals shape will be fixed. There is no any change in the shapes of the atomic orbitals. But in the case of the molecular orbitals, here the shapes, the change will be there. In the shapes of the molecular orbitals, the change will be there. Those are not fixed shapes. The molecular orbitals are not having the fixed shape. It is actually the shape of the molecular orbital will be depend on the how the atomic orbitals will come together to form the molecular orbitals. Depending on the orientation of the atomic orbitals and hybridization of the atomic orbitals. Okay, here. Yeah, here the depending upon the hybridization of the atomic orbitals, here we have the shapes of the different shapes of the molecular orbitals. Is it clear? Yeah. In the molecular, but in the case of the molecular orbitals, we are not having the fixed shapes. That means the molecular orbitals can change their shapes. The molecular orbitals can change their shapes depending on the hybridization. How the atomic orbitals will come close together, and how the orientation of the lobes will be there in the atomic orbitals, and how the hybridization can take place. Depending upon these things, the shapes of the molecular orbital will be there, isn't it? Depending upon these circumstances, here we have the different shapes of the molecular orbitals. Okay, these are the main differences between the atomic orbital and molecular orbitals. Okay, then we will check about the differences between the bonding molecular orbitals and anti-bonding molecular orbitals. Okay, yeah, coming to the differences between the bonding molecular orbitals and anti-bonding molecular orbitals. Here we have few main differences between the atomic orbitals, that is bonding molecular orbitals and anti-bonding molecular orbitals. Okay, yeah, we'll see what are the differences between the bonding molecular orbitals and anti-bonding molecular orbitals. In the first point, the bonding molecular orbitals are formed by addition overlap. The bonding molecular orbitals are formed by the addition overlap of atomic orbitals. While in the case of the antibonding molecular orbitals, the antibonding molecular orbitals are formed by the subtraction overlap. Here we have the subtraction overlap. That means the antibonding molecular orbitals are formed by subtraction overlap of atomic orbitals. Here we have the addition overlap of atomic orbitals. Here we have the subtraction overlap of the atomic orbitals. And the formation of the bonding molecular orbital is constructive interaction, while in the case of the formation of the anti-bonding molecular orbital is destructive interaction. It is the constructive interaction and it is the destructive interaction. Yeah. Coming to the next point, here the bonding molecular orbitals, to form lobes of the atomic orbitals should have the same sign. To form the bonding molecular orbitals, the lobes of the atomic orbitals which are comes together to overlap, those lobes should have the same signs. Okay, the lobes of the atomic orbitals should have the same sign to form the bonding molecular orbitals. But in the case of the antibonding molecular orbital formation, the lobes of the atomic orbitals should have the different signs. Okay, whatever the atomic orbitals are going to overlap, those lobes of the atomic orbitals should have the different signs in the formation of the antibonding molecular orbitals. Okay, and here the bonding molecular orbital energy is lower than that of the constituent atomic orbitals. The bonding molecular orbital energy is lower than that of constituent atomic orbitals energy. Well, in the case of the antibonding molecular orbitals, the energy of the antibonding molecular orbital is higher than that of constituent atomic orbitals energy. The energy of the antibonding molecular orbitals are having higher than their constituent atomic orbitals energy, isn't it? And the next point, here the bonding molecular orbital, the electron density is higher. Here we have the electron density is high in between the around the nuclei of bonded atoms. Okay, in the bonding molecular orbitals, the electron density is high around the nuclei in the bonded atoms. While in the case of the antibonding molecular orbitals, the electron density is low between the nuclei of the bonded atoms. Okay, and finally we have one more point. The bonding molecular orbital actually imparts the stability to the molecule. It can give the stability to the molecule. Due to the formation of the bonding molecular orbitals, the molecules will have the stability. Well, in the case of the antibonding molecular orbitals, these antibonding molecular orbitals imparts the instability to the molecule. Okay, due to the antibonding molecular orbitals, here the instability is imparts to the molecule. Okay, these are the main differences between the bonding molecular orbitals and antibonding molecular orbitals. Okay, in this session we have learned about the differences between the atomic orbitals and molecular orbitals, and differences between the bonding molecular orbitals and antibonding molecular orbitals. Okay,